Hello, welcome to my channel where there's always you inside my heart. Okay, today I'm gonna continue about the easiest way to understand Geant4 part 2. Now we are focusing more to the material definitions. I'm Ozzy and let's get started. Okay, first of all, before I explain to you about this Geant4 material definitions, I want to tell you that I studied this Geant4 during my study at France, and I use it to complete my master thesis in CA. Unfortunately, I still have not got any chance to study directly from CERN about this Geant4. Maybe next project, maybe? Hope so. Okay, now what is material definitions in Geant4 and why it is a very important part? Well, if you look again to the fundamental of the Geant4 simulation software, it will bring you like how the matter interact, how the source interactions with matter. The source can be like from gamma ray, X-ray, photon energy, or something like that, and the source in electron volt. Okay, this source and contact with the materials, and then they can be scattering, absorb, or what else, whatever it is, but it depends on the material that you describe in here. So Geant4 will give you like a customized material settings. Of course, this is where if you guys are the scientists, material scientists, and want to develop your materials and want to know if this material interactions with electron, gamma, or something like that, and you want to visualize these interactions, it's very possible, of course. And of course, there's also like a standard material inside this Geant4 and written in NIST library, okay, something like that. So you can call it this material by call NIST library. Okay, now to define material, you can do it by two ways. First is calling the NIST library, and second one is using the manual. Using the manual, if you have something like customized material, so you have like different compositions of material. It can be material, compound material, or mixture material, and maybe change the density and value or something like that. You can do this. In Geant4 simulation software course. And there are three main classes in Geant4 isotope and Geant4 elements. Both of them are described prototypes of the atoms. But today I'm not going more forward to the Geant4 isotope because I think it's much more a little bit tricky. So for the basics, the Geant4 basic, like right now, I think it's I will not recommend it to you to go forward to the isotope. Okay, just focusing on the Geant4 element, and also another one is the Geant4 material. And for Geant4 material, is described a macroscopic properties, including if you want to define one element to be a material or compound or mixture. So okay, let's check it out, how to use this kind of material definitions. Okay, and then in material definition, there's also physical attributes. So there's you should define like a density, atomic number, and the atomic mass. Okay, you can let it go, make it easy for the temperature, pressure, and state. You don't need to like to state how many temperature that you needed or something like that. Just leave it, and Geant4 will describe it by default. So you for right now, we don't change any temperature, pressure, and state, only focusing on the density, atomic number, and the atomic mass. But we need to describe these attributes if we declare or we define it manually. If you define it by NIST library, by call the NIST library, you don't need to define the density, atomic number, and the atomic mass. Okay, now, okay, this is the element. So this element is, okay, let's assume that we want to describe a single element called lead. Okay, and then this lead has the atomic number of 82 and the mass, the atomic mass of 207.19 gram per mole. And then you have two options to define this material. So first is the using NIST library, and the second one is the define it manually. Okay, if you compare between the NIST library, and then define it manually, is much more simpler, right? So it's only you just need to type the Geant4 material, and then this is the name of the material. You can write it whatever you want it. Maybe lead 1, lead 2, or LD or something like that. It's up to you. And then equal to the NIST. This is a mass, and then then you just find or build material Geant4 PB, and then close it by the semicolon. Okay, and you should to memorize. You should to remember that because the Geant4 using a C++ software program language programming, so the uppercase and the lowercase is very sensitive. So if you define your Geant4 material and then lead in here but using the uppercase of L, and then when you want to use this lead and then into your material, inside the geometry, and then you call it lead with the lowercase of L, and then it will be error when you want to compile it or when you develop this your software. Okay, now if you define it manually, the name is the same. You can write it down. It's up to you what the name is, and then this one is you should to insert like something like new Geant4 material, and then this one is the name of your lead, and then this one is PB. It called is PB, and then this is a sign, something like that, and then this is the number, the atomic number, and this is the mass, the atomic mass. Okay, so you should to describe it clearly inside your material definitions. Okay, how to use this kind of material definitions? Okay, before I told you that lead can be written as an element or material. So this one, if you want to describe it into a single material, not single element. And this one also, if you want to describe the material. So what is the difference between a single material in here? Lead is the name is this is the same, but compared to the previous one. So what is the difference? The difference is if you have like a mixture or compound letter, you need to describe the element first. That's the clue. That's a mass. Okay, so if you don't describe the element, you cannot call the material. Especially if there's like a compound or the mixture material. Okay, maybe we will see it later after during the example in here. Okay, so we have we are going back to the Geant4 example in here. It is a B1 example actually, and in the inside the B1 there's like two geometry. There's two geometry in here, a box one and another one. Okay, shape one and shape two, and this transparent one is in the box. The transparent box is a mother box. Okay, so we will change the material in the shape one, okay, to be 15 centimeter in wide and 5 centimeter length and 15 centimeter high. Okay, so we have a we need to declare it how much for the x, y, and z. Okay. Okay, this is the energy that we are going to use during our simulation today. Okay, we will go to the using gamma and with 2 mega electron volt of the energy, and there will be 200 particle of the gamma during these simulations. Okay, now we can go forward to the simulation. Okay, so first you should to open the terminal and then go directly to the folder that you put your script. Yeah, your source script, of course. So first I need to go there. So cdw work and then ls cd Geant4. Okay, I'll S again and then CD. I put it in the exercise, and then okay, I have B1 PB, B1 PS. Okay, just ignore the B1 PB1. Okay, in here there's a PS and PB. What is the PB and PS? Maybe you can see again in my previous video, but basically we will work at PB and PS. Yeah, PS is for the source and PB is for the builder. Okay, now in here I need to open another terminal, so I need to go to the file, new tab, and then I have two tab in here, right? Two terminals. Okay, for first terminal I will go directly to the source, of course, the project source, so I need to go to the CD B1 and PS, yeah, project source or program sources, and then this one. Okay, and then if you check it out, the what is inside the B1 PS, and then I think I need to go again to the SRC. Okay, this one is consists of the all of the project that we want to like develop. Okay, now in the second one I need to go to the B1, and then but this one is PB. Okay, now we will develop or make our program in here and running the program in here, and this one is when we want to change the code. Okay, but maybe we need to make sure that our project is, our program is can be run it. Okay, so I need to run it first. In here is because it's already there's in here this executable in here, example B1. Yeah, because I did it before in the previous video, and then okay, now we run it again first, and then okay, we have this kind of geometry and detector. So first, before maybe because we want to change this kind of material of the shape one, so maybe I can test the default one, so with this kind of parameter, right? Maybe I can make it smaller. Okay, so particle gamma 2 mega electron volt and 200 particle, right? So first is gone particle gamma. Okay, if you sorry, don't use space in here. Okay, so perfect now. So, and then I need to go to mention the Geant4 software about my energy. Gamma energy is 2 mega electron volt. Okay, if you scroll it down again and see there's okay, and then now I want to run, and then beam on to 100. Okay, and run it. Now if you see there's a lot of the gamma energy is go through paths of our samples in here. Okay, now maybe I can write it down. Okay, going down, and you can see that. Okay, I will put and make a note in here. Is I think the name is I forget what is the name is. Shape 1 material. So in the shape 1 material we have score, right? We have score for more about it's about 1.62, yeah, pico gray. Okay, and then with the RMS it's more or less is 0.39 or 8, something like that, of pico gray also. Okay, so we can exit this one and see. Okay, now we are going to work with our detector, so we need to edit our script. In here I'm using gedit and then b1 detector construction.cc and then run it up. Okay, perfect. Okay, now if the first running is we are using the niche shape 1 material. It's a tissue material. You can check it out maybe what is the material it is, but yeah, the default one of the B1 B1 example is using the Geant4 150 TCU, something like that. Okay, now we need to create now our own material, right? So maybe we can use, because this one using material, the first one is using material, right? Okay, so we need to use a material also. So in here I need to describe a lead, so I will change this shape 1 material into lead. So how can I proceed? Okay, maybe to make it more beauty, I will write it down, the element 1, element definitions, and also there will be material definitions. Okay, good. Now what I need to do is working with describing my element. Okay, now maybe okay, if you see this one is there's a Geant4 needs manager, and then needs equal to the Geant4 needs manager instance, something like that. This code is to call the Geant4 library. Yeah, this is called needs library. So this is it means that you tell the Geant4 that we want to use needs library. Okay, and then we can go further to go to the Geant4 material. Okay, this is, and then we want to create material, the name is lead, and this one is needs, and then this one, okay, something like that. And then find or build material, okay, okay, and the name is Geant4 PB. Okay, good. Don't forget to close it with a semicolon, okay, and then okay, perfect. And then now we can check it out if our material definitions is working or not. So just okay, going down, okay, just change the shape 1 material into the lead, okay, finish and save it and close it, and then go to the second terminal and make it. Okay, make sure there's no error in here, and then if there's a warning in here, shape material, it means because we declare there is a shape 1 material, but we are not using. So okay, this Geant4 only just mention us that there's something like that. Okay, now we can proceed it to the explain, okay, and then okay, now we do the same. Yeah, we proceeded the same way. So first is for the gun, okay, particle and using gamma, right? Okay, and then run again, gun energy and 2 space MEV, of course, and then run again, beam on 200, okay. Cannot sorry, not beam on, but it's beam on, beam run, don't use the uppercase one. Okay, now we can see that with the same particle with the number 201 200 particle, and we see that there's like only several of them can go through past our material, right? And if we check it out, the score in here, okay, maybe I can write it down in here for the lead material, and then the score will be decreasing, okay, 0.74 picogray, and in here also 0.27 for DRMS, yeah, 0.278 picogray. Okay, perfect. Now we can exit. Exit. Okay, now we can go more further about this manual define about the element. Like as I said before, the element is we need to define this element if we want to define material which is use this element. For example, when I define the nitrogens, oxygens, and argon, and then it means I want to if I want to define the air material, okay, so maybe I can go forward with this one. So first, okay, I need to go again to the first terminal, and then go edit, and then in here, okay, and then in here I need to define element, right? So in the element in here, go forward, okay, this one. So in here I need to define Geant4 element, okay, and then with the symbol of and in here, and I need to say, I need to tell the Geant4 that there's a new Geant4 element in here. Okay, the name of the element is the nitrogens, and okay, the name of the N is the nitrogens, and the symbol is the N, of course, and then the atomic number is 7. Okay, this is there's no unit in here, so there's only the atomic number, and then the mass of the atomic mass is about 14, but right now there is a unit in here, so the unit is in gram per mole. Okay, perfect. But okay, but now if I save it and then run it, it will be an error because we need to declare Z and A. Okay, so how do I do that? So because we proceed with not there's like a comma in here, so I cannot use I cannot proceed the integer, so I should to go forward by the double. It means Geant4 double and then Z and A. Okay, and then close it. So I tell the Geant4 that I'm gonna use Z and A. Okay, perfect. So okay, now I need to do the same for oxygens and the argon. Okay, see this one is for oxygen and with the uppercase of O, and this one is the argon. Okay, with the symbol of the argon in here. Now oxygen have 8, the number of 8, and the mass is 16. Yeah, it's 15.9, something like that. And this one is 39, right? 0.94948 gram per mole, and this one is 18. Okay, good. Before we are proceeded this material definitions. Sorry, this is material, this is element. Okay. Okay, I need to replace this one because it should be in here. Okay, perfect. So in the element and the material. Okay, now I need to save it right now. So this element in the element, and then this one is the material. Okay, before we are going to define our air material, we need to check it out if there's an error or not during our material definitions. Okay, save it and close it and make it again, but we don't need to run it. So make it and make sure there is no error. Okay, so perfect. Now maybe I need to clear it out, and then okay, go again to the first terminal, and then go to the edit again, and then in here we can proceed our air definitions. Yeah, air material. So in here I need to go to material definitions. So I have an air material with density. Like as I said before, I want to describe the density. Okay, so in the density, and then 1.204, and then this the unit is about kilogram over meter cube, and then okay, this is my density, the air density, and then Geant4. material, and then this one is for the N2 because we need to define the nitrogens first, and then this one is new Geant4 material, and then okay, and then this one, the name of the material is the molecular nitrogen. Okay, perfect. And then I just need to write it density, and then number of atoms is equal to 1. What is the 1 meaning? It means because I only use the n element in here, one n element. Even I want to describe the n2, so when I need to put the 2 in here, so I need to define the n2 in the next line. So in here no, in here I need to go like this one and add elements, and then the name of the element is n, right? And this one is 2. Okay, so it means that I am using one element. It is n nitrogen element, and then because the compositions of the nitrogen is n2, so I just simply by write it n2 in here. Okay, perfect. Now let's proceed to another one, is the oxygens, right? So this is the oxygens, and I need to change the name also to be an oxygen, and then okay, with the still the same with the number of atom equal to 1, and the element is 2, but in here I need to change to O2. Okay, good. Now okay, now I need to define air. Okay, in here I just put material called air material with the same density, and right now I am using three elements. It is NON-AR, right? Argon. So in here now I call it air and add material instead of the element, because I will use these nitrogens and the oxygens. So I said this one is N2, right? Yeah. And then in here I can use a percentage in here. So its percentage is 0.1, and then this one is %. Okay, just make sure that you are using a C in the uppercase, not the lowercase. Okay, good. And then you need to proceed it again with the same. Okay, and then this one is the O2. Okay, and then 21, and this one is 0.8%. Nice. Okay, so we have all that we need. No, this one is argon, and this argon I'm using not material, it's element. Okay, good. Now in here as you see that I use density in here and also number of atoms. So the number of atoms is cannot be it should be an integer, and so that's why I need to declare it Geant4 integer, right? And the name is atoms, number of atoms. Okay, close it, and in here I just I just define another parameter called variable and density. Okay, now everything fine, so I can save it, close it, and then see if it will if it's we have something error or not. Just go to the second tab and make it again. Okay, perfect. Sorry, I forgot to change our material in here. Maybe because we already have second material is called air, so we need to maybe change our box material in here from lead to air. Okay, save it and close it. Okay, go again to the second terminals, make it perfect, and then do the same process. Okay, and then good, and then okay, so gun particle gamma. Okay, gun energy to MeV. Perfect, and run again. Beam on to 100. Okay, see if you see and you check again. Okay, the end is okay. I will write it down, our score now. It's increasing again, right? It's 3.1337, something like that, in picogray. Okay, with the RMS equal to 0.5, yeah, 0.58. Yeah, because it's look like there's because our material is an air, so there's no material in here. Okay, good. Now we can exit the program, exit, and then okay, go again in here. Okay, in here density of the air. Okay, you can do the same for the water element if you want it, and check it out again if is work or not. Yeah, but is the basic idea is still the same. So you should to describe the element first, and then the density of the water, the number of atoms, and then this one is because it's yeah, because H2O is only just H and O, and then this we have H2 is the atom is the number of atom is 2, and using one atom of the oxygen, so you just need to write it down, the number of atoms 2 and the number of atom of the oxygen is 1. Okay, if you try it, and maybe you can let me know if you have been tried or not in the comment sessions. Yeah, you can write it down, and if there's any problem in here, you can also ask me in the comment sections. Okay, now everything is good. Now the last one is much more just like a tricky one, because I need to define the lid glass. So yeah, this for the lid glass, because you want to define the optical one, you need to define like not only the materials itself, but you need to define like the number of entry, like a photon energy, refractive index, and something like that. So it's very tricky in here. So if you so you don't need to know, maybe you don't need to worry about what the value came from here, because you can find it out from the internet, and then you can write it down. Yeah, this is only for the example, and then maybe I will explain to you about this one more in the advanced one in the next session. But for right now, we can try it this one for the leaded glass. So okay, we need to go to the first one, to the first terminal, and then go again to edit. Okay, now we need to define this lead glass, right? Okay, for the lead glass. Okay, for the lead glass, we can define something like this one. So constanta, it's constanta, the Geant4, the Geant4 integer, the number, of entries of the lead glass is equal to 2. This number, you can increasing this number or you can decreasing this number. Is depend on your needed, of course. Okay, and then this one is the Geant4 material, and then yeah, it's the same, still the same with when you want to define another material, of course. But now for much more easier, I just use I call the needs library, yeah, because it's much more simpler. And then in here I need to define something like this one, so I just need to copy paste, maybe in here, copy, and then here, but now the name is lead glass. Okay, Control C, and then need to change this one, and this one. Okay, and then new Geant4, and then I call it lead glass, of course. And then the density is much it's about, okay, I can define it here, or I can make it equal to 4.46. Okay, maybe I will do the same procedure with the previous one, so I will make it in here. So in here I need to write 4.46. okay, now in the gram per over 3 centimeter cube, and then okay, that's it. Okay, and then this is the density. Then the atomic number is I am using 3 atomic number. Okay, and then the name is the leaded glass, and then this one is PB. No, sorry, this is also lead glass, right? Okay, I don't need, okay, sorry, I don't need this one because I already have this leaded glass, so I can let it go for for the manual definitions. If you want to create definitions, you need to write this one is the density with 4.46 gram, and then this is the material, but you need to build the PBO and the silicon dioxide and thallium dioxide, something like that. This one is equal to the, for this one. So in here you need to the PBO, so you should to Geant4 material PBO, and then the number of atom is equal to 2, because you need you need to use the PB and the oxygens, right? Okay, good. And then so I can go further to the the photon energy and the refractive index in here. So just copy it, and then okay, yeah, because now I'm just I'm lazy enough to write it all of them, and then but okay, so you should to write the Geant4 double photon energy is about 2.034, something like that, and then the refractive index, because you need to write it down. If you don't write it this refractive index, and then you will not proceed to the the optical parameters in Gen4 simulation software. Okay, perfect. Now, okay, now we need to tell the Gen4 about this kind of the photon energy and something like that in here. Okay, so okay, so after we describe all the parameters that we needed, then we need to do another thing, yeah, to run this simulation. So we need to define the, okay, this one is the for the Gen4 properties table. So they will it means the all of the calculations, that measurement or something like that, it will be written into a specific properties table. Okay, in here. Okay, but okay, I need to rearrange of this one again. Okay, okay, to make it, I will rearrange this one to make it easier for you to see clearly what is the code. Maybe I can make it this one. Wait, why? Where? Okay, and then this one is for the scintillator. And then this one is number of entries. Y is okay. Okay, and write this one also, and then okay, perfect. So this is the script that you need to write it down. Okay, so there's a little glass in here, and then you need to mention about the photon energy absorption, number of entry of the lidded glass. Okay, and then this one is okay, do the same with this one. Okay, also you need to mention about the constructions properties. Okay, okay, perfect. Now copy. Okay, the last one is lidded glass set to the material properties table. So we should to mention this one before we can proceed it. Okay, and then this one I need to save it and then close it and then check if there's an error in here or not. Okay, perfect. I forgot, I need to change it, the material definition, right? So in here again I need to change to the lead glass, not the leaded glass one, but I need to change to lead glass in here. Wait, the material is the lead glass. Okay, and then I need to change to this one, to the lead glass. Okay, save it, close it, go to the second one, make it. Okay, perfect. Okay, now we need to proceed the same way. So gun, then particle gamma. Okay, you can scroll down and then see if it's work or not. Then again we need to describe the energy of 2 MeV, right? Okay, perfect. And we need to run beam on 200. Okay, see. Okay, now as you can see there's several of gamma energy still go through paths, but let's see. I think the end of this one, the number of the energy, okay, this one is 1.1. so now I need to write the lead glass, right? And then score is 1.16 picogray. Okay, and then the second one, this the RMS is equal to 0.338 picogray. Okay, good. Now we know that everything is working. Our definition is, there's no error in our definitions, but yeah, especially for the optical one, maybe I will tell you more about it in the advanced one in the next maybe in the next sessions. Okay, but for today, for right now, it's only check if it's work or not working. Okay, but everything is good right now today. Okay, it's quit. And then if you can see that for the shape material, and when we change the to the lead, and then the difference with the leaded glass, yeah, because you know that the density is more dense in lead compared to the leaded glass. That's why there's only a few, if you see that with the 2 MeV, from the shape 1 to the leaded glass is only just a few, just a less material, yeah, score, and then compared to this one, the lead is much more good to block the energy, the gamma energy. Okay, now maybe that's what I can explain to you about these material definitions. If you need to go more for reference, you can go to the NIST government. Yeah, this is for the energy. You can compare it, and then if you need to more definitions about the Geant4, like the material definitions, you can the optical material, you can go to this website. And also if you want to for the material, another material definitions, you can go to the CERN website. Okay, that's what all that I can explain to you for today. Thank you very much for your kind attentions. And okay, if you have any questions, you can write it down in the comment section below, or you can go to my Instagram. Okay, it's already in here. You can scan the barcode or something like that. Okay, thank you very much, and see you in my next video of the Gen 4 simulation software part 3 next time.